We will be discussing about this problem, control of project costs. So the subcontractor responsible for the construction of the substructure of the turbine house for a new coal-fired power station decides to install a cost control system in order to facilitate the clerical procedures so that the feedback is possible each week. Only labor and plant are considered. Hello, can you hear me?
Yes.
Okay. Only labor and plant are considered. Materials control is dealt with in a separate system. The main site functions. So here, can you see me? What thing I have highlighted?
Yes, we can.
Site functions.
The main site functions. Okay, yeah, because I was confused, so that maybe I am reading some other file. Okay, so the main site functions, which can be carried out by stable gangs of workers, are given code numbers against which actual costs are recorded as follows. So you can see that these codes have been given to different types of costs of code 10, 20, 30, 40, 50, 60, 70, and 80. And if we just read these codes quickly, so earth moving has one code, reinforcement fixing for gang X and Y have two codes, carpenter for gang X and Y have two codes, concrete for gang X and Y have two codes. And then there is an overall code for the project overheads. So the contract plan of construction is shown in this table, and the budget for this work in table 2, okay, in table 2 below. At the end of week 37, the current progress is recorded as shown in table 3. So, and the actual costs to the end of week 37 have been recorded and are shown in table 4. So we have a series of tables. So the first table, this table 1, tells you the approximate dates for the different activities. So in this case, we have A, B, C, D, E, F, G. 7 activities we are considering. And for their plan scheduling, their starting date and their duration has been given. So based on this, we can make a kind of plan for this project. And in table 1, so remember that table 1 is the scheduling data. Table 2 gives you the data about the costs, okay, for these 7 activities. So for example, starting from A to G, we have these 7 activities, and there we know that we know their total costs of these activities. So what is the total cost of activity A, B, C, D, and up to G? And then if we add all these costs together, so 954 is the cost of these 7 activities. So each of these costs, for example, for activities, so activity A and activity B, C, D, and each of these costs has been subdivided into their relevant cost codes. So for example, activity A only involves a cost code 10 and cost code 80. So if you look back, what is the cost code 10? It is the earth moving, okay, gang cost and the project overhead. So project overheads are included in every activity, in every activity. Similarly, uh, for B, so we have these three costs. So for example, 20 is for reinforcement, 40 is for 20 is for reinforcement, 40 is for carpenter, and 70 is for concreting. So if you can see that uh, we have for turbine hull, uh, retaining walls, turbine plinth, and floor slab to the turbine hull. So in this case, uh, the turbine area has been assigned with the gang X, okay, gang X, and then they are doing their respective reinforcement uh, uh, of carpentry work, that means related to the form work and the concreting. And the other other work is two works are related with the uh, cooling tower pump house. So in this case, the excavation crew is involved, and then there is this car, uh, gang Y has been involved for the formwork, uh, reinforcement, formwork, and carpenting. And then there is this project overhead. So in this case, by just looking at this data in the table, we can have a kind of mental image for this project. So there are mainly two gangs, gang X and gang Y. And then there are additional crew for the excavation. So these are the uh, two main crews which are working over here, and then these are subdivided into different crews as well. Okay, so this information, and the next information which we have over here is in the table 3, which is the progress at the end of 37 weeks. So by the progress which the end of 37 weeks, we have this information. So for example, for each of these activities, uh, A, B, C, D, E, F, G. So we know that what is the uh, actual start of the actual starting date, and then what is the projected completion date. Okay, so so this type of information we can use to find the actual to calculate the actual progress of work on the project. Okay, so progress of the work. So we can calculate the percentage complete for each activity. So if the activity has been completely has been finished, so that means the percentage completion on that activity will be 100%. Okay, so table 4 is the actual cost to the end of week 37. Okay, so what was the actual cost? Okay, so on these within these weeks. And next is we have to do is we have to plot the budget curve for the full contract and the value and the cost curve to the end of the week 37. So in this case, we have to draw the budget curve, value curve, that means the earned value, that means which is related with the actual progress, and the cost curve, that means the actual cost. Okay, so in this case, then we have looked at this data once, and now we can decide on whether we can plot these curves or not. So for this, we can look at this data. For example, table 1. So for table 1, data is for the the data in the table 1 and table 2 can be combined to plot the budget curve. So for the budget curve, then we need for each activity, we need the start and finish date of the project. So we can create an approximate schedule for this case. So what we can do is maybe I can input a table between here, okay, as a solution. So I can insert a table, insert a table, maybe, I don't know how many columns I need. Let's see. So let me say that the first column is for activity, and then we have like how many activities? A, B, C, D, E, and F. Okay, so we have these activities, activity A, B, C, D, F. So when the activity start, so activity A start at, so this information we already know. So activity A, B, C, D, E, F, and then there is this activity G as well. So activity G. So I can input this data over here, okay? Or maybe I can put the, I think maybe instead of the start, I can put the data for the duration first, okay? Duration. Okay, so the duration is 15, 15, 18, 22, I like that. So I can input this information, copy and paste. No, okay, maybe like this, okay. So, and then the start is starting from here, starting at the, okay, so this is the start. And when will this activity end? So then we can just, from the start, can add the duration. So 0 plus 15 is 15. 4 plus 15 is 19. 15 plus 18 is 33. And then 19 plus 22 is, yeah, 19 plus 22 is 41.
41, then 42.
42.
34.
Plus 25 is 34.
And 42.
Plus 33 is, so 9 plus 33 is 44. 44, right? Mm-hmm.
42.
It's 42. Yes, 42. Okay, 42. So this is the start and then this is the end. So based on this information, we can plot a curve. Yeah, so we can create the Gantt chart actually for this. And now the cost, total cost. So total cost is here. Total cost is here. No, oh, what happened? Okay, so this is the total cost, 141. So, so we can use this information now for our further analysis. And what further analysis which we can perform is, now we can note down the actual start and actual finish of this. So for example, when was it actually started and when was it actually finished, and what is the status at the end of week 37. Okay, so in this case, what is the status at the end of week 37? So this is for the whole project. Okay, so for example, now if I add one column over here, and this is the plan for the whole project. So now we are taking a status at the end of week 37. So at the end of week 37, what is the what should be the status of week A? Activity A. So the plan. So we can add a column for the planned status. Okay, planned status for week A. So this activity A should be completed. Yeah, should have been completed. Okay, so it should be completed. Okay, because it was scheduled to finish by the end of week 15. And similarly, this should be completed. Okay, and then this should be completed. How about this? This activity should be in progress. Okay, or not completed. Okay, not completed or in progress. Okay, that means, or we can just say that started. Okay, started but not completed. This activity, yes, this activity also started, and then this activity should be completed. And how about this activity? Started. So therefore, at the end of week 37, our planned status is like this. So what is the actual? So actual start, actual start. So what is the actual start for this? That we can see that in this the progress by this table. Yes, from here, from table number 3. So actual start is this. So we can add it over here, and actual or planned finish. Okay, projected finish. So actual or projected finish. Okay, so now based on this, actual status is actual status. What is the actual status over here? So yeah, so it has already finished on day 15. Okay, and these two activities, so completed, and then similarly this is completed, this is completed, this is in progress. Okay, in progress or not completed. Okay, yeah, I don't know which word is to use better, maybe in progress or started. Okay, in progress. Okay, in progress, or just use the word progress. Okay, progressing. Okay, and then what is this? This one is also in progress. How about this? How about activity F? Hello?
Completed.
Yeah, completed. completed, and then this is in progress. Okay, so this type of information, let me just make some space over here. Just a minute. Okay, so where I was at? Okay, so yeah, I was here. So this is completed. Okay, here. So now what we have over here is, so for example, if we say that it's completed, then for those activities which are in progress, then how many percentage of those activities has been completed? Okay. So in this case, what we can do is maybe okay, so I can add one more column, percent complete. So for those completed, then that is the 100% complete, 100% complete, 100% complete. And then for those in the progress, so what is the progress? So what is the, how many percent that activity has been completed? So for example, in this case, we need to look at this activity, activity D. So what we can say about this activity. So for example, we are at the end of week 37. So at the end of week 37, we can say that this activity is going to complete on week 46. So how many weeks are remaining in this case? So 46 minus 37, which is how many weeks?
9.
9 weeks. So 9 weeks are remaining. And what is the actual duration of the, so 9 weeks are remaining. So what is the duration of the activity? 22. So 22 out of 22, and so for example, from actual start is 23, and then it is finishing on 46. So 46 minus 23 is 46 minus 23 is 23. Okay, and then that means 46 minus 20. So this activity is going to complete in 23 weeks. Okay, so out of 23 weeks, 9 weeks are remaining. So which means that 14 weeks work has been completed. So 14 weeks work has been completed, which is as a percentage of 23 weeks duration of the project. It is equal to 60.86%. Okay, so it is the percentage completion is 60.86. But actually, in this case, what we are doing is we are calculating it with respect to the actual start. However, from the planned duration point of view, so we will take 22 days. Okay, so it means that out of 22 days, 14 days of work has been completed. So 14 divided by 22, which is equal to 63.6%. Okay, it is 63%. So what do you say? What is the percentage completion in this case? How can we calculate it? So it's starting in at the end of week 23. So that means 24, 25, then that means it is 23 weeks. Or 23 out of 23 weeks now, 9 weeks are remaining. So 23 minus 9, that means 14 weeks of work have been completed. 14 weeks of work out of 23 weeks. So it gives us the answer about 60.86%. So percentage completion in this case is 60.86 or 60.9%. Okay. How about this? So it is also similar, something like this. So 24 and then 48. So how many days of work is remaining? 11 days of work. 11 days of work out of how many days of activity? 48 minus 24, which is 48 minus 24, which is 24 days. So 24 days and then 11 days of work have been completed. 24 minus 11, that means 13 days of work has been completed. So 13 divided by 24, so which is equal to 54.16%. Okay, so which is equal to 54.16 or 2% of the work. This has been completed, so it is 100%. And how about here? So actual or projected finish is 48 days, 48 weeks. So which means that 11 weeks still remaining. 11 weeks still remaining, and then it started on week 13. So 48 minus 13, that means it will take like how many days, how many weeks? 35 weeks. So out of 35 weeks, 11 weeks are remaining. Okay, so it means that 35 minus 11, which is 24. 24 weeks work have been completed out of 35 weweeks. So which gives us about 68.6% of work has been completed. So this is the percentage complete. Okay. So now if we have the percentage complete, then what we can do is we can calculate the earned value for each activity. Earned value. So earned value of each activity is equal to the cost for the activity multiplied by the percentage completion. So the cost for the activity was A was 141. So 100% of 141, it will be 141. And then it will be 171, 195. And now for this one, it is because it is 60.9%. So so it is 98 into 0.609 will be 59.7. Okay, 59.7. And then its cost was 161 times 0.54%. So it will be 86.9. It will be 86.9. 86.9. And here it will be for F, it will be 122, 100% complete, and it is 68.6% complete. So 66 times 0.686, so it will be 45.3. So 45.3. So in this way, we have calculated the actual progress as well. Okay, so we have this data, and then further we have this data. Okay, so budget values. So based using these percentage completion values, so we can as a percentage of these values, we can assign these cost values to these different cost codes. So for example, since these A, B, C are the three activities, they have been 100% completed. So these cost code values will remain the same because these were already given for 100%. And but for the from the earned value perspective, activity D, which has now 60.9% completed. So if we want to reflect the progress in this table, so 98 will be replaced by this value 59.7. Okay, and then alternative accordingly, all of these costs. So, for example, 6 will be as a percentage of this value. That means it will be 60.9%. So 6 will become 60.9% of that. That will be about 3.75, and then similarly other costs. So this table can be updated based on this information. So what was actually asked? It was asked that we have to plot the budget curve, value, and the cost curves. So for this purpose, we need to plot it. So for plotting these values, so for what we can do is we need to draw the Gantt chart. Okay, and Gantt chart we can plot in Microsoft Project or other project management software. But for simplicity, maybe we can just plot it in the Microsoft Excel as well. So let me show you over here if we want to plot these curves, because we need to know what are the values what are the total values or cumulative values after every week that we want to know. So for this, maybe I can copy this data from here, and then I open it into the Microsoft Excel. So I have opened the Microsoft Excel. Can you see the Excel worksheet?
Yes.
Okay, so I have copied this data over here, and now I want to somehow plot this data by the activities. So for example, if I have this data over here, activity, activity A, B, sorry, A, B, C, D, E, F, and G. And then I have the duration and like that. Maybe I can just plot it over here as well. So for example, if I say like it is, yeah, let me add one. So this is week 1, this is week 2, and like that. Okay, so maybe I can add those weeks over here, 1, 2, and like that. So since the project is going to end at around week, go up to week 48, so I will need to plot those 48 up to 48 over here. Yeah. So I have plotted it 48. Maybe I can. Okay, so here in this way I have, so activity A. So activity A is from planned is from 0 to 15. Okay, so 0 means actually 1. Okay, 0 means starting from week 1. Okay, week 1. So at the end of start, 0 means at the start of week 0. So sorry, 0 means at the start end of week 0, which means start of week 1. So 1 to 15. So this is activity A. So yeah, 15 weeks. So as you can see, as maybe you can see 15. So it will be 0 to 15. This will be activity B, and then I will highlight it with say yellow. Okay, and activity B is activity B. Where is activity B? Here, and this is from 4 to 19. So from 4 to, at the end of week 4 means start of week 5. Yeah, 4 to 19 here. Yeah, 5 and then 19. Okay, so in this way it will be this activity B. Activity C, where will be activity C? Here. Activities from 5 to 33, 15 to 33. 15 to 33 means from 16th to 33 here, here, right? 16 to 33, so I will highlight it over here. And then activity D is from 19 to 41. 19 means 20 to 41 here. Okay, yeah, this shows the activity D. And now we have which activity? Activity E. Activity E is from 19 to 42, so it's same as here. And then it is 42. Yeah, 42. Maybe I can show it with some other color. Okay, to just, and activity F is from 9 to 34. 9 means 10. Here, 34. Yeah, here. And then, okay. And then the last one, activity G, from 9 to 42. So 9 means 10, and then to 42. 42. Here. Yeah, 42 is here. So this is maybe, okay. Okay, so let's use the alternate colors. Yellow, green, yellow, and then maybe some other color over here. Blue. So in this way, we have kind of represented this project. So now what we can do is, so for example, if we want to put, so we have this type of data over here, okay? So this is, this was activity A, and this was 100, the total cost for activity A was 141. So what I can do is maybe I can put some insert a column for, and then insert one more column over here. So it will be, I will activity and then the cost column, okay? Over here. And now I can just, so for example, this activity A will be distributed over this duration. So therefore it will be for how many days? From 1 to 15. So 141 divided by 15. So it will be 141 divided by 15. It will be 9. Okay. And then I will distribute this activity, distribute these costs over the full period. And then this was for how many days? 171 costs. So this is 171 is 171. But for how many days? This for 171 is for how many days? This was also 15 days. Huh? No, it was for 22 days. So divided by 22 days. So it will be 8. And then if I copy it over here up to now, so it will be, no, no, so 171 was for how many days? It was also 15 days, okay. So 171 divided by 15, so it is 11. And then if I add it, so the total should be 171, that's correct, okay. The next is for 18 days, okay. So this is 18 days, total cost was 195. 195 divided by 18. So it is 11 again. So I distribute these costs, so that is 195, okay. And 98 was for, this cost was 98. 98 was for how many days? Yeah, so 98 was for how many days? 22 days, okay. So equal to 98 divided by 22. So it is about 4 something, and then so yeah, so the X correct. And then this cost was 161. So 161 divided by 123. So it will be equal to 161 divided by 23. So it is 7. And for how many days? It is, yeah, okay, correct. And then the last two are remaining. So this is 122 over 25 days. So it is equal to 122 divided by 25. So it is approximately 5. Okay, and then is distributed 122. And the last one is this one, 66 over 23 days, 33 days. So 66 divided by 33. 66 divided by 33 is 2. And then this is 2, 2, 2, 2. Okay, so now I have this information over here. Which is maybe okay. So I have this data. So now I can add up these totals. Okay, I will use the sum from this activity 8 up to activity this, and then I will add these sums. Okay, so I have this data for the weekly costs. And then what I can do is I can add up these cumulative values. So first value will be this value, and the cumulative value will be equal to this value, current value plus the sum of the previous values. So it will be 19, and then I can. Okay, so the next will be for you to yeah, so these are the cumulative values. So these cumulative values can be plotted against the weekly values, okay? And then that will give us the curve for the budget curve, total budget curve. So we can plot it. So for example, we can use this data. So for the plotting of the data, what we can do is I can, for example, I can select this data, and then I can select this data and insert a chart using Microsoft Excel. Insert, which one? Insert, yeah, here. I can plot the XY chart using the curve. Yeah, so I will get this curve, okay? So this is the budget curve, or it is called as the S curve, okay? So similarly, you can get a curve for your earned value as well, okay? And then you can plot this different curve. So the other curve, for example, will be up to 37 weeks. So there will be some curve over here that will be up to 37. And then there will be some other curve which will be for the actual cost as well. In fact, the time has been almost complete. I could not complete it, but I will upload the solution of this exercise, and then you will look at it later on by yourself. So, do you have any questions about this?
Yes, hello. I have a question. What does EV stand for? We understand that it is some kind of value, but uh, what is the full name of this acronym?
Uh,
EV,
EV, EV is the earned value.
earned value.
Yeah,
Oh,
EV is the earned value. So this is normally taught in the project management course. Uh, Earned value, actual cost, uh, planned value, cost variance, schedule variance, cost performance index, schedule performance index, uh, estimated cost at completion. So there are several terms which are there. And I think if you have taken this project management course, then you should be familiar with these terminologies.
yes. Thank you.
Mm. Okay, so on next Wednesday, there will be a quiz, and then we will also do a part of that lecture for some more quantitative problems. And I will also give assignment number 3. That assignment number 3 will be an online assignment. That means you will solve the questions on Moodle. And within today, I will provide you the details.